Let the function f of x equal 3x to the fifth times 4 minus x to the eighth. We want to find all critical numbers of f. So for that, let's take the derivative. We have to use a product rule. The derivative of 3x to the fifth is 15x to the fourth, and then times 4 minus x to the eighth, plus the derivative of 4 minus x to the eighth. You have to use a chain rule, so bring down the power, subtract 1, and then take the derivative of the inside, which is negative 1, times 3x to the fifth. Now I can factor out a 4 minus x to the seventh, and then an 3x to the fifth, sorry, 3x to the fourth. All I'm doing is just looking at the minimum exponent of x to the fourth, x to the fifth, and then 4 minus x to the eighth and 4 minus x to the seventh. Finally, 15 and 8 times 3, the GCF there is 3. So I can have 5 left over times 4 minus x, and then minus, I need a 8 and an x here. So I'm going to simplify this. Then we have 20 here, minus 5x minus 8x is negative 13x. Set this equal to 0. That means we're going to set 3x to the fourth equal to 0, 4 minus x to the seventh equal to 0, and 20 minus 13x equal to 0. Here we get x is 0, x is 4, and x is 20 over 13. Now let's determine if f of x has a relative maximum, minimum, or neither at each of the critical points. So for that, we're going to use the number line. So we have 0, and then 20 over 13, and 4. So let's test these different regions. The good thing is that 3x to the fourth is always positive, but these two could be negative. So let's see. Let's say negative 1 here. 4 minus negative 1 is 5. That's positive. And then 20 minus 13 times negative 1, that's positive as well. Positive times a positive is positive. Let's try 1 here. Yeah, 4 minus 1 is positive. 20 minus 13 is positive. So that's positive. For this one, let's try 2. That's positive. That's positive. So 4 minus 2 is positive, and then this one is negative. So positive times a negative is negative. And then we can try, let's say, 5. 4 minus 5, that's negative. And then 20 minus 13 times 5, that's also negative. Negative times a negative is positive. So if the derivative is positive, it means f is increasing. If it's negative, f is decreasing. So at x equals 0, we have neither, because the sign of the derivative doesn't change. It's positive, positive. At x equal 20 over 13, it changes from positive to negative, so there's a max there. And at x equals 4, changes from negative to positive, therefore it's a minimum.